we've been studying Newton's laws of motion, and we've been applying these laws of motion to rigid, free bodies. But in our study of rigid, free bodies, we've had to introduce people, and people different from rigid, free bodies are deformable. We can change shape. In this video, I'd like to introduce a simple language by which we can use our understanding of rigid free bodies to describe the more complicated deformable bodies. So what I've shown here is a picture of a person pushing against a block, a rigid block, and what would happen if that person pushed against the block would be that the block would end up moving, and as the block ends up moving, the person's arm would stretch out. And what we can see then is that although we can move in very complicated ways, typically in the kinds of problems we're dealing with, it's a very simple motion. So we can treat, in this particular case, the person as having a deformable part of their body, the block, but then in addition to that, they have a rigid portion, which is the rest of the person. And what we're going to do then is we're going to consider the deformable part, in this case the arm, just like the ropes in our pulling problems, as massless. And the part of the person whose motion is not important, we will consider rigid and with mass. Let me give you a simple example of how this could be useful. When I was little, I was told the story of a Chinese historical figure, Xiang Yu, who was a famous general, and he was said to be so strong that he could pick himself up by his head, by his arm. He could pick up his whole body. And that, of course, is not possible. And we can use our description to see why that is. So in this case, it's the arm again that is the deformable part. So, and the rest of the body is rigid. So I'll put a block around the rigid part. That's the rigid part of the person, and this is the deformable part. This is deformable and massless. I'll make it a different color. That's the arm. It's deformable and massless, and the rest of the body is rigid with mass. And the good thing about a massless object is that Newton's second law says that the mass times the acceleration is the sum of all the forces. So if it's massless, the sum of all the forces must equal 0, and that means that we know all the forces on this deformable mass arm must cancel out. So here, this arm is pulling on the person upwards. So we'll show that. The person is being pulled upwards. By Newton's third law, the massless arm is feeling a force of equal strength in the opposite direction. And since the arm we've assumed is massless, there must be another force canceling out the force I just drew, which is at the other end of the arm. I'll put it here. So these two aqua forces are on the arm and cancel each other out. And then by Newton's second law, a third law, there must be a force on the rigid part, the rest of the body, in the opposite direction. I'll show it here. And this diagram then proves how impossible that story is, because by applying Newton's second and third law, we see that the rigid part with the mass is feeling two forces shown in green here, which cancel each other out, and so that arm isn't lifting anybody. Okay, and what we're also going to look is at problems which are like this. Here's a person, and the person's hands are going to be pushing one block, but at the same time, their feet will be pushing the block the other way. And so the motion is going to be, here's the person, and they're going to end up extending outwards. And the one block will move this way, and the other block will move the other way. Okay, so when we're describing this situation, we have what's happening here that we want to take into account is that part of the person's mass is staying with the horizontal block, and part of the person's mass is staying with the block which is moving to the right. And so the way we're going to describe that, since now we're interested in the fact that the person's mass is, some of it is going to the left and some is going to the right, we're going to describe this deformable body with the following language. What we'll do is we'll make the people, we want the thing that's actually doing the most, the motion to be deformable. So let's circle the person, and that's going to be a massless object, a massless portion, the part of the person that moves is massless and deformable. And part of the person's mass is going to be stuck with the one block, so I'll put a little block here. That's part of the person's mass that's going to stay with the block on the bottom, and another part of the person's mass will stay with the vertical block, which I show here. And so now, when we describe this new situation, we want to have, we want to keep our picture of the person because we want a picture of how things are changing. What we're going to do then is keep one block here. This is the mass that stays with the block on the left, and this is the mass that stays with the block on the right. And this language will then allow us to treat the deformable person who has mass. What we're going to do is consider one part, which is doing the deformation, being massless, and we're going to put mass wherever we feel in this particular problem it's most important for us to consider it. And we'll be using this technique in the next video.